Okay, this is a review of our latest version 2.0 PLC software for our Ozone generators, our control system. I'm going to review the basic operation. First screen we have here is the main home screen. It shows the current output of the generator, the system mode that you're in, the system status if it's in fault or running, cabinet temperature, and oxygen percent in this case. That oxygen percent does change depending on the type of system you have. That could also show dew point or nothing at all if you don't have any air quality monitoring system on it. So we go to the menu. From here's your main navigation menu. You can navigate back to the home screen. You can go to the control screen where you would set your running mode. The lights illuminate green to indicate what mode you're in. If you want to just purge gas flow through the system to prepare it for operation, just hit the purge button. System will immediately start purging, bring the system up to the pressure that you want at the set gas flow, and just purge indefinitely. From there you can immediately go into the run mode that you want, or of course turn it off. There is a purge off delay when you hit off or go from any running mode. Currently set for 10 seconds. So you'll see here after 10 seconds it will pressure will go down and gas flow will stop. We currently have this in remote mode for the analog input. If you want to run it locally just from the generator, you'll use the local button here, and then you specify the output percentage you want from the local output percent input. You set this anywhere from 0 to 100%, and the generator will run at that set level indefinitely. You can see we have 50% indication on the output signal. That's the signal we're sending to the inverter. After it goes through its start delay, you'll see this switch to Ozone on. The actual output of the generator is then indicated here. This is a reflection of the percent of actual output that the generator is producing. That should normally mirror the output signal. If it does not, you could potentially have an issue with the inverter, or might need to check into that. If I switch back to the control screen, I can change that output to any number from 0 to 100. Go back to home, and you can see it's now down to 25%, and the output percent is also reflecting the same signal. Now if we use remote mode in this case, you switch to remote. At that point it is now using the analog input from an external source to ramp up and down the generator, or if you have it in Modbus control mode, you can send that signal via Modbus to ramp the generator up and down. Now we're going to go ahead and simulate a remote signal to ramp that output up and down. So if your external control system was ramping up and down, as you can see we're starting to ramp up. Output signal is increasing, and the output percent is following suit. So with that external input, that could be from any other control system. External PID control could be used. Remote SCADA system. Again, that's either via hardwired 4 to 20 signal or a Modbus signal over the Ethernet. This control system is Modbus TCP capable, and it's set up for that if you activate it in the setup screens. Go back to the control screen. So that's remote mode. The only difference is that you don't use the local output percent when you're remote. Local utilizes the local output percent mode. Okay, go back to the menu. We can check our alarm list. From this screen, it displays all the various interlocks that are currently enabled on this system. External hard shutdown is often tied to like a backflow device, maybe an injector pump, anything that will cause the generator to go into a hard shutdown and power off. E-stop would be in that category. can see feed gas pressure. External interlock could also be considered an external run command. That one also, the external interlock can also be received via Modbus if you have that enabled. Feed gas flow, feed gas or cabinet temperature, inverter fault, ambient ozone, and air prep. All these will give you a red or green indicator indicating if they are okay to go or not. The Modbus COM OK over here is grayed out because we do not have Modbus enabled, and this is currently green just because we are not requesting that we have a Modbus signal. These are based on a watchdog signal that would be sent over the Modbus if you're using that mode, so that you know you have a constant connection to the primary control system. So these aren't really relevant unless you're in Modbus control mode. I'll go ahead and demonstrate one of these inputs. So for example, if we have an external ambient signal, Ozone will shut off, and immediately on an ambient you will get a pop-up message that says that the ambient's been detected. You need to check for leaks and basically troubleshoot your system. This does require an acknowledgement of this to make sure that an operator has seen it. So you acknowledge that fault. You can see the ambient ozone is still faulted. When that does clear, you'll notice it does not immediately start back up. If you go back to your control screen, you'll see that the ambient reset button is now flashing red. That indicates that the ambient has latched, and it requires operator intervention to get the system back online again. Because we don't want the system to continually try to restart if there's an ozone leak. It requires an operator to address the situation. You can also go to your alarm log and search that. You can see that here we had an ambient fault. It did recover, but you can see that the ambient latched has not recovered yet because we have to push that button. So we go back to control screen. I can hit ambient reset. Now we'll notice that system will start back up again after the preset start delay. There, we got a blue light on our generator. This one has a blue lamp indicating that we're making ozone, and then it starts back up. Go back to the alarm log, and then we can see that the latched ambient alarm has now recovered as well. So looking at the alarm log briefly, you can scroll down, up and down, and look at all the history of alarms. It tells you the date and time that it occurred. The recovery time just gives you the time. It doesn't give you a date. If you do want to clear this, you can delete the log, but it does ask for a confirmation to make sure that you don't want to delete anything that may be irrelevant that you need to have stored that you don't want to keep clear. So ask for that confirmation. If you do in fact want to delete it, go ahead and hit delete. If you don't, hit cancel. Okay, the next screen we can go into is the settings screen. This does change relevant to the settings of the system currently. From this screen, oxygen set point, again, will only be relevant if you have oxygen enabled on this system. It could also be dew points or nothing if you don't have any feed gas quality monitors on the system. This one is set for the ozone on delay. How long do you want it to wait before the ozone production starts after you activate the system? It is preset for a minimum of 10 seconds to make sure that the system has time to energize and power up before it gets a run signal. To change any of these, you just touch the field, and then you can change that to whatever setting you need within the range, acceptable range. Oxygen set point, that is the percentage that it will only allow the system to run if you're above that percentage. On the opposite side, if you're using dew point, that value would be the maximum value. It would need to be below that dew point, set point, before the system would operate. So the oxygen versus dew point is slightly different. Purge delay is the number of seconds that it will flow gas after a shutdown situation to make sure that it purges the gas out of the system. It's always best to get the ozone out of the generator before it completely shuts down to make sure that there's no ozone in there to bleed back through the non-ozone resistant parts that can be damaged, such as the gas flow meter, the pressure regulator. Any of those things can potentially be damaged if you get ozone to them, because they're not ozone safe. Go back to the menu. Factory is a factory setup screen, the configuration. End operators will be given that password as needed to change custom configurations. I'm not going to go through the password in this section of the video, but that's where you would set up the type of a control, type of generator this was. So most of that stuff is reserved for the initial setup of the generator. Quick review of the entire system. Take a look here. On this particular generator, you can see we have the ambient ozone monitor that will detect any leaks in the system. We have our gas pressure for the system, that is the cell pressure of the gas. Feed gas flow tells us the current flow rate through the generator. Down here we have an electronic pressure regulator. This pressure can be preset from the HMI to specify the pressure we want for the system. If it drifts from that pressure, this SMC pressure sensor will detect that and trigger a fault if you're too far out of range. The nice thing about this electronic regulator is that anytime gas flow is adjusted to the system, it will automatically readjust itself to maintain constant gas pressure within its limits of its feed gas supply. Over here you see we have our oxygen monitor. This monitors the feed gas quality and gives us our concentration indication on the HMI as to what our current percentage of oxygen is. That would help us to detect if there's a problem with our oxygen concentration. Equipment, feed gas quality is poor. We'll know it by this monitor here. On the side of the generator, we've got a feed gas control. This is what regulates the gas flow through the generator. Like I said, the pressure regulator will automatically readjust pressure to maintain our target if you readjust this pressure. We also have all these systems, as I said, were Modbus compatible. We have Ethernet port on the side and a bulkhead fitting where you can connect a computer, SCADA system, or a technician can plug in a computer with the maintenance software to troubleshoot any changes or upload new programs to the PLC. We have our primary on-off switch here to turn the main power off, and then down here we've got outlet gas valves for the feed gas in and feed gas out for isolation. These may or may not be on every generator. This one is on a skid mounted system, so it's got additional valving for system control. That's a basic overview of our new generator. Thank you.